Rocks form fairly large units of the Earth's surface. The distinction between minerals and rocks is that minerals are homogeneous substances that exist as crystals or grains, whereas almost all rocks are aggregates of mineral grains or crystals. A few kinds of rock, such as volcanic glass, however, are not granular. Most rocks are mixtures of two or more minerals, but a few consist of grains of only one mineral. Examples of this are pure sandstone, composed of quartz, or pure limestone, composed of calcite. Rocks are divided into three main classes, called igneous, sedimentary, and metamorphic. Metamorphic rocks are formed from igneous or sedimentary rocks by changes in temperature or pressure or both, which took place deep in the Earth's crust and resulted in the rearrangement of elements to form minerals that were more stable under these change conditions. Some rocks of the general metamorphic class contain minerals formed partly by the addition of elements to pre-existing rocks by processes causing diffusion of elements. Sedimentary rocks are those which are formed by sedimentary processes, such as limestone, which was formed in an ocean environment, or sandstone, which was formed in a dune formation, or as a beach deposit. Geologists use two kinds of classification for rocks, one of which can be applied in the field by ordinary observation or with a pocket lens. The other, more detailed classification can normally be applied only after laboratory studies, such as examination with a microscope or chemical analyses have been performed. Almost all igneous rocks are crystalline, although most have an interlocking rather than a crystalline texture because of the almost simultaneous growth of grains from the cooling magma. Under special cooling conditions, however, well-shaped crystals develop. If these are larger than the remainder of the rock, they are called phenocrysts, and the rock is called a porphyry. In most igneous rocks, the common rock-forming mineral is one of the feldspar family of minerals, generally accompanied by smaller amounts of quartz. These minerals are generally light in color. Other important rock-forming minerals are those containing iron and magnesium, called ferromagnesian minerals, such as hornblende, pyroxene, olivine, and biotite. These minerals are dark. There are also many accessory minerals, such as magnetite, which occur in almost any kind of igneous rock in small amounts that do not affect the classification. Igneous rocks composed mainly of feldspar and quartz are commonly called acid rocks, and rocks lacking quartz and containing much ferromagnesium material are basic. Other terminology used are siliceous or felsic for rocks containing much quartz or feldspar, and phemic or mafic for the ferromagnesian rocks. In these relatively coarse textured rocks, such as granite, the grains can generally be seen with the unaided eye. Plutonic rocks are classified primarily according to the amount and kind of feldspar and the amount of quartz or ferromagnesian minerals they contain. The general kind of feldspar present can commonly be estimated by the unaided eye or with a hand lens, but for some rocks this is difficult or impossible. In detailed studies, these groups are further subdivided into numerous varieties based on microscopic or chemical studies. For field purposes, it is sufficient to use the following distinctions. Granite is a relatively light-colored rock composed of potash feldspar and quartz. Many granites also contain relatively small amounts of white mica, biotite, or hornblende. If the rock contains relatively large, well-formed crystals scattered in a matrix of ordinary granitic material, it is called a granite porphyry. Syenite is a light-colored rock composed mainly of potash feldspar. Little or no quartz can be seen, even with a lens. Diorite is a fairly dark-colored rock composed mainly of plagioclase feldspar with considerable amounts of one of the amphibole family of minerals, commonly hornblende, or one of the pyroxene family. Other common types are granodiorite, containing appreciably more plagioclase than potash feldspar, and quartz diorite, containing more than 10% quartz. Gabbro is a dark-colored rock composed mainly of calcic rather than sodic plagioclase, commonly labradorite, with large amounts of amphibole or pyroxene. With decreasing amounts of ferromagnesian minerals, gabbro grades into anorthosite. Ultramafic rocks consist almost entirely of the ferromagnesian minerals olivine or pyroxene, or both, with little or no plagioclase. They are generally altered to serpentine minerals. They characteristically weather an orange-buff color and have dark green to black fresh surfaces. Magnetite formed during alteration to serpentine causes the rock to be weakly to moderately magnetic. Rocks that are formed in dykes and sills are commonly finer grained than their plutonic equivalents, but some, such as many diabases and pegmatites, are coarse-grained. Other common types are aplite and diabase. Aplite is a fine-grained, evenly textured rock equivalent to granite in composition and commonly displaying a sugary surface. Diabase is a rock nearly equivalent in composition to gabbro, commonly having characteristic arrangements of lathe-shaped crystals called diabasic texture. Besides occurring as even-textured rocks, many of the classes of rock may be porphyries. They are usually named according to the composition of their phenocrysts. Common examples are quartz porphyry, feldspar porphyry, and hornblende porphyries. Another common kind of dike rock is pegmatite, a coarse-grained rock formed under special conditions that permitted the growth of large mineral masses or crystals. The commonest examples are granite pegmatites, composed essentially of large masses of feldspar and quartz, from about a ½ to a foot or more in diameter. They may also contain crystals of mica, apatite, and many other minerals. More rarely, pegmatites are encountered whose compositions correspond to syenite, diorite, or gabbro. The rocks of dikes and sills and volcanic rocks may be too fine-grained to permit field determination of the constituent minerals. In such cases, the general term felsite and trap are used for light and dark-colored rocks respectively. Volcanic rocks correspond in composition to one type or another of plutonic rock, but tend to be fine-grained or glassy and have some distinct features. Their fine-grained size makes it sometimes difficult to recognize the constituent materials and to name the rock, although the general color may be of some assistance. Volcanic rocks may be even-textured or porphyritic. Porphyries are usually named according to the kind of rock and may be called by such names as rhyolite porphyry or andesite porphyry. But they may also be classed according to the kind of phenocrysts and be called by names such as quartz porphyry or hornblende porphyry. Many volcanic rocks contain small holes or vesicles left by gas or steam and are termed vesicular. If some or all of the vesicles are filled by a later formed mineral, the rock is said to be amygdaloidal. Volcanic rocks of basaltic or near basaltic composition are commonly segregated into pillow-shaped masses caused by flowage underwater or at least in a very wet place. Rocks that are in one sense volcanic and in another sedimentary are formed as a result of volcanic explosions that shatter material which had crystallized in the throat of the volcano, causing ejection into the air of large angular fragments, or small fragments that form volcanic ash. When materials of these kinds falls to the earth, it may be deposited in layers on dry land or in bodies of water and later become rocks. Those containing large fragments are named volcanic breccia or volcanic agglomerate, and the finer grained ones are called tuff. They are distinguished according to their composition, such as rhyolite tuff or andesite breccia.